Hello, everybody. This is Mr. Tam back with another episode of Science. Now, this is, of course, directed more towards our EST students who are working towards doing chemistry and or physics next year. So today's topic is going to follow up on the last one in that it's called stoichiometry, yet again. But rather than deal with mole ratios this time, we're going to deal with mass. Dum, dum, dum. Now, of course, seemingly very daunting like the last one, it actually will not be as hard as you think it is. So we're going to start off with a very basic reaction here. I'm going to call this the Haber process, basically taking nitrogen, reacting it with hydrogen, and getting 2 moles of ammonia. And what's interesting about this is I balanced it for you right away. Don't always assume that it's going to be balanced for you. Make sure that you do end up balancing. So today's question is that if I'm giving you 2.40 moles of H2, I want you to predict the amount of ammonia that's going to be made. Well, we did this last time, and we were able to do it with moles and end up with another amount of moles. Today, what I'd like to do is expand on that and have you find the number of grams of this ammonia. So how do we go about doing that? Well, this particular question is a two-step process. Number one is the actual stoichiometry step, where you're comparing the actual ratio that you see to the actual amount you have. So what that means is I know that for every 3 moles of H2, I end up producing 2 moles of ammonia. And knowing that, I can match up what I'm given, which is 2.40 moles of H2. And, of course, an unknown number of ammonia. So N in this case is equal to, if I cross multiply, 1.6 moles of NH3, which falls in line with that ratio. Now, it's all good if the question asks you to stop there, but we're going to take it a step further in converting the number of moles to mass. So, in this case, I first need the molar mass of NH3. Now, I'm only going to find the molar mass for one of these questions out of the 3 that I'm doing today. The rest of the time, I'm just going to list out the molar mass because I will assume that you will have practiced enough that you're able to find it very easily. So nitrogen has a molar mass of 14.01, and hydrogen has a molar mass of 1.01, but 3 times. So this ends up being 17.04 grams per 1 mole. I'm going to use this ratio to figure out the amount of grams I have for ammonia. So this is my original amount, but I don't actually have 1 mole. I have more than that, which means I have 1.6 moles lined up with the 1 mole. That being said, my M is my missing amount, which leads me to M is equal to, when I cross multiply, 27.3 grams of ammonia as my final answer. And there you have it. So it's a 2-step probability where this step is actually the stoich step, okay? And this step is just a conversion step from moles to mass. So if you guys want to copy this down, try it again on your own. That would be wonderful. I'm going to now move on to another problem, another variety, where you're essentially given manganese and oxygen. Now, there's a name for this one, okay? A lot of people might say, oh, well, don't worry about it. So it's just manganese oxide. But since manganese is part of our transition metals, we have to actually put a Roman numeral. So that particular manganese would be called manganese 4 oxide. And I challenge you guys to figure out why we call it manganese 4 oxide rather than just the one that we see right there. So these are the products that it produces. And of course, you notice that I've balanced it for you yet again. So here I give you 17.4 grams of manganese 4 oxide, and I want you to find out how many moles of HCl that gives you. Well, if the first step requires mass and something to do with moles, then for sure you know that you need the molar mass. So the molar mass of manganese 4 oxide is 86.94 grams per mole. I'm going to use this amount in a proportion setup. Now you notice that I'm not being lazy here. Every single time I write out anything, I'm writing what I'm talking about. So here I have 17.4 grams of manganese 4 oxide and an unknown number of moles, of which when I cross multiply, I end up with pretty much 0.200 moles. It's a very nice and a nice number that it worked out to be. So given that, of course, that's not what I'm actually interested in. Now for the stoich part. What I'm actually interested in is the hydrochloric acid, or the HCl. So I know for every 4 moles of HCl, I have to react it with 1 mole of manganese 4 oxide, which leads me to lining up 0.200 moles of manganese oxide, or manganese 4 oxide, for an unknown number of moles, and N in this case ends up being grand total of, what did I calculate here, 0.8. Wow, surprise, surprise, 4 times the amount of manganese 4 oxide, because the ratio is 1 to 4. So that being said, take a picture, take a snapshot, try out the problem yourself. Whatever way you want to do it is good. I'm now going to go on to the last type of problem, which in my opinion probably is the toughest type. And once you master this, you will be good to go for anything. So let's look at our classic reaction of reacting propane, which we find on the barbecue, of course, reacting with 5 moles of oxygen to give me 3 moles of carbon dioxide and 4 moles of H2O. If I were to give you 40 grams of oxygen and ask you to predict the amount of carbon dioxide in grams, this is where it gets tricky, where you have to go from grams to grams. But in reality, it's just a 3-step process. First, the molar mass of oxygen is 32.00 grams per mole, because each mole of oxygen is 16. And since it's O2, it's 32. Now, we're going to set up our ratio like we did before, 32.00 grams per 1 mole. And this, of course, we're still talking about oxygen. And this is equal to the amount that's given, which is 40 grams over an N number of moles. So N is equal to, in this case, 1.25 moles of O2. That's the actual amount. And I'm not interested in the actual amount of oxygen. I'm interested in the actual amount of carbon dioxide. So this is the second step where you're actually doing the stoich, and it is 5 moles of O2 reacting or producing 3 moles of CO2. So it's a bit of a weird ratio, but as long as you set up a proportion, it's not very difficult. So you have 1.25 here moles of O2 in comparison to an unknown amount of moles of CO2. But you do know that when you cross multiply, you can figure out the number, and that number happens to be 0.75 moles of CO2. Now, it's all fine and dandy if I said I wanted to know the number of moles, but because I want to make your life difficult, I want to find the amount of mass of CO2. So I then go ahead and find the molar mass of CO2, which happens to be 44.01 grams per mole, 12.01 grams from the carbon, and 32 grams from the oxygens to give you this number. And of course, like every problem we've done, we're setting up a ratio or a proportion where it's 44.01 grams per 1 mole of CO2. And I don't have a whole mole this time. I have only 0.75 moles of CO2, which means I have a total amount of 33 grams of CO2 when I go to cross multiplying, therefore finishing my problem and solving the age-old conundrum of stoichiometry. So I hope this video will help you guys out. Please make sure to like and subscribe, and keep yourself safe in these very, very uncertain times. This is Mr. Tam signing off, and I will see you in the next video. Au revoir, arrivederci, bye-bye.